Have you ever stopped and just wondered what makes something beautiful? Why certain things, certain patterns just seem to catch your eye? Well, it turns out there's a kind of secret code behind it all, a hidden language of design. And today, we're going to crack that code. I mean, just look at this butterfly. Yeah, the colors are gorgeous, of course, but what really pulls us in is something else. There's this perfect balance, right? A harmony in its shape that just feels right. Or how about this intricate Rangoli pattern? Did you notice how those red petals pop up again perfectly every time you make a quarter turn around the center? It's a design that's built on this really cool, deliberate repetition. And then you've got these incredible architectural marvels, like the Taj Mahal. There's this undeniable sense of harmony here, a kind of perfect order that our brains just find so satisfying. So the butterfly, the Rangoli, the grand building, what's the one secret they all have in common? What's the thread that ties all of this beauty together? Well, that secret, that common thread, is symmetry. It's this basic idea of repeating parts in a very specific pattern. It's a language that nature, art, and even science all use to create a sense of order and beauty. Okay, so let's get right into it. We're going to start with the most common type, the one you probably learned about back in school, the perfect fold. This is all about reflection. A line of symmetry is basically an imaginary fold line. If you could actually fold a shape along this line, one half would land perfectly on top of the other. I mean, an exact match. And we have a perfect name for these two identical parts. We call them mirror halves. It's the best way to think about it, right? One side is just the perfect reflection of the other. Let's actually see this in action with a simple square. Okay, so you can fold it in half vertically, that's one line. You can fold it in half horizontally, that's two. But wait, we're not done. You can also fold it perfectly along one diagonal and then again along the second diagonal. So a square doesn't just have one or two lines of symmetry. It has exactly four different ways to get that perfect overlapping fold. But hang on, this brings up a really good question. Is a diagonal always a line of symmetry? For a square, yeah, absolutely. But try it with a rectangle that isn't a square. If you fold it along its diagonal, the corners just don't line up. The two halves don't overlap at all. And this just shows you how specific the rules of symmetry can be. Okay, so line symmetry is making sense. But then you see something like a pinwheel. It definitely feels symmetrical, doesn't it? But try to find a fold line. Go on, try it. You can't. There is no single line that creates two mirror halves. So what's going on here? To figure out the pinwheel puzzle, we need a whole new kind of symmetry. This one isn't about folding. It's all about turning. This is symmetry in motion. This is called rotational symmetry. And the idea is actually pretty simple. If you can spin an object around a central point by a certain amount and it looks exactly the same as when it started, well, then it has rotational symmetry. Let's go back to our trusty square to see how this works. Just imagine we've labeled the corners so we can keep track of what's moving where as we spin it. Okay, so if we rotate it 90 degrees, just a quarter turn, look what happens. The shape itself looks identical. Even though all the corners have moved, the square is sitting in the exact same spot. Let's go another 90 degrees. That's a 180-degree turn from where we started. And, yep, once again, it's a perfect match. One more turn takes us to 270 degrees, and it still looks the same. Every one of these stops at 90, 180, and 270 degrees is what we call an angle of rotational symmetry. And here's the beautiful pattern behind it all. The angles of symmetry are always just multiples of the smallest angle that works. So for our square, the base angle is 90 degrees. For something like an equilateral triangle, it would be 120, and so on. Okay, so we've spent some time looking at symmetry, but what about actually making it? Let's switch things up and go from just being an observer to being an artist. You can literally do this right now. It's a total classic, the ink blot test. Just fold a piece of paper, put a few drops of ink or paint on one side, press it together nice and firm, and then open it up to reveal your creation. You just used a line of symmetry to make something totally new and unique. And that really simple activity shows you that symmetry isn't just some abstract math concept. No way. It's a creative principle. And once you know what you're looking for, you start seeing these amazing patterns absolutely everywhere. So let's quickly recap the two main keys to the code of beauty we've unlocked today. First, you have line symmetry, which is all about creating those perfect mirror halves. Then you have rotational symmetry, which is the magic of the perfect turn. And these two ideas can combine in incredible ways. I mean, get this, the Ashoka chakra has 24 lines of symmetry and 24 angles of symmetry. It's just a complete masterpiece of order.
We've seen how symmetry creates beauty through perfect order, through perfect repetition. But that leaves us with one last thought to chew on. Now that you know the rules of the game, where do you find the beauty in breaking them?